Ah, yes, Mr. Meeseeks, and he's going to be here to help us out with matrix multiplication. Welcome to assignment 3 for CS302, and I guess you guessed it, we have threading. And of course, Mr. Meeseeks is there to help us represent what a thread object is. And we're going to be using sort of this approach to multiply matrices in parallel. So this problem is actually a well-known problem in algorithms, is multiplying two square matrices, both of the same size, and we can compute them using a divide and conquer method. Now, of course, you can optimize this even further, but we'll go over the very straightforward divide and conquer approach to this problem. So let's look at the PDF in more detail. So this is going to be essentially your formula. Now I'm going to go over sort of in more visual so you can see how this works. But really, this is all there is to this. So if you have matrices A and B, and A11, A12, A21, A22, and for the B matrices respectively, it's not going to be single elements, but these are going to be just sort of four quadrants of these matrices. So if A is an 8 by 8 matrix, then each quadrant will be these we'll have four of these 4 by 4 matrices, and so forth. So I'll do an actual example, so using the OneNote to sort of visualize all this. But essentially, here's going to be the formula right here as to how we compute this resulting C matrix. So just again, just a recap, it's going to be sort of a square matrix. So we're going to have A and B. Their dimensions will be the same, and they'll be powers of 2. So it'll be 2 by 2, 4 by 4, 8 by 8, 16 by 16, and so forth. So they're both going to be the same size, and they're going to be powers of 2 for their size to make this problem a bit easier to work out. And then this formula right here is going to essentially help you. This is going to be your guide, essentially. So each multiplication of A11 with B11 like this, or A11 with B12, and so forth, that's going to just be multiplying a submatrix with a different submatrix. So A11 will be a submatrix, so will B11. You multiply them, and when you multiply this submatrix, A11, B11, and also A12, B21, you can already notice that these can be done in parallel, and that's going to be the parallelism of this program. So each multiplication can be done in parallel, but of course, adding the results up, you have to have some sequentialness to it. So you're going to have to use a set of mutex locks to allow it, so you don't have a race condition going on. We don't have two threads at the same time trying to write to a specific location in the C matrix. So really, that's really essentially all there is to this program. So I'm going to first just go over this PDF, and I'll go over the details using OneNote in a second. So the input really is going to be, you're going to read in an input file name from the user, and you're going to open a file stream, and the file stream will contain the following data. You're going to first have a number n at the very top, which tells you the dimension of these matrices. So let's say if n is 4, then you're going to be having two 4 by 4 matrices you're going to have to read in. If n is equal to 8, you're going to have to read in two 8 by 8 matrices, and so forth. So of course, at first you read in n, and then you're going to go ahead and read in those matrices afterwards. And then for the output, you just sort of output C matrix without the quotes, and of course output that product matrix. So I guess specifications for this program. Of course, you may have to have some variables be global. So for your A and B matrices and your C matrix, those could be all global matrices, because each thread is going to have to process a part of the A, B, and C matrix. You may as well make them global. Now, of course, you're going to have to pass in a set of arguments to each thread function that tells the thread which part of the A, B, and C matrices you're going to be processing. But the matrices themselves, A and B, C matrices, can just be global, and even your array of mutex locks can also be global as well. Then of course, it should be multi-threaded. I guess I should have put this here in the comments, or here in the specifications, but documentation is always important. But the last very important concept is, if, let's say, you do use UNLV servers to compile your code, let's say you do, that's fine. do not use Bobby or Sally or any of the other servers. Please use Cardiac, this server name right there, if you do use these school servers to run your program. So Cardiac is a special server that's going to sort of terminate any threads that run forever. Whereas Bobby and Sally doesn't have a protocol for those. So let's say if you have a thread infinitely looping, then that could sort of, crash Bobby and Sally, but Cardiac would not have this problem. So use Cardiac for this if you're going to use a school server. But anyway, here is your sample run of your program. So I compile it using my pthread flag. Here's my main program. I run it, enter a file input1.txt, and this is going to be the product matrix to be output. And the same thing for input 2. This would be a larger matrix, and here is the result right there. So that's all you really have to do in your program. Just display this matrix at the very end, just like that. Let's go ahead and just sort of go back. Let me first sort of show you what the input file you can expect to see. Then I'll go over just sort of a high-level sketch of how you want to work this program out. So here is one of the input files you can expect to see. So this is, obviously have the user will type in input02.txt. You read in that file name. You open a file stream, and here's what's going to have to be read in. So you first read in the number 8. So then, of course, you're going to have sort of these two-dimensional vectors A, B, and C. And you're going to set them to be both 8 by 8. And then, of course, each line is going to be matrix A. And then this is going to be matrix B. So you're going to have 8 numbers per line. Each line is separated by an end-of-line character. But of course, you can just use that input, what's it called, the extraction operator, because every number is separated by some form of a white space. So you have spaces here, and also a new line is also a white space as well. But of course, you can use a get line, and you can parse each individual component from that line, but really using the input stream operator is the simplest way to actually read this in. So that's going to be your first step. Read these two matrices into A and B. And of course, your C matrix will also be 8 by 8 matrix as well. But of course, you want to make sure that you have every element in that C matrix just be all containing the value 0. Okay, so now let's go ahead and go over our high-level view of this algorithm. Okay, so right here we have our matrices. So I have A and B matrix. So let's say they're both 8 by 8, and we can divide A and B into these 4 quadrants. So I label each quadrant accordingly, and each of these will be 4 by 4 submatrices. And of course, here's my C matrix here, using my fancy space pen to actually label this one. So let's go ahead and just first look at the very straightforward, simple way of being able to multiply 2 matrices. So the obvious standard way of doing this, let's go ahead and use pink. So we would go ahead and look at this first row and multiply it to every element of this column. That's our standard matrix multiplication algorithm. And of course, we take each element one by one. So we take this element, multiply it with this one multiplies with this, and so forth, until eventually multiply this with this at the very end. We add all those up, and we're going to store that right here in our C matrix. And then, of course, for our next element, I'm going to go ahead and remove all of these. We do exactly the same thing, but with this next row. We multiply all the elements in this next row with all the elements in this column of B, and we're going to store that result right over, let me see, I think right here. So don't quote me on this if I made a mistake, but I think it goes right there. So that's how you can do a standard matrix multiplication algorithm. Now, of course, you want to do this more in divide and conquer approach, and in terms of in a parallel version. So, of course, you can test your code. You can just simply copy and paste that code online somewhere to test to make sure. But of course, on CodeGrade, all of the example input and outputs will be there for you to test it out with, but of course you can create your own simple sequential method just to test out your sort of your algorithm. Let's first go over just a more divide and conquer approach. So if I were to, let me just see if I can use these, I'll use this ocean pen. Let's try this one out. So I'm gonna go ahead and box this area in. Ooh, looks kind of nice actually. Just the well, actually, it's probably gonna be too hard to see this. Let me just use a regular, so not use the ocean pen. That would be a little complicated to see this. Let's go ahead and use this. This is definitely better. So let's go ahead and I'm gonna get this one. I'm going to multiply this submatrix with this submatrix. What this does is it computes a portion. So it's going to, if I multiply this submatrix A11 with B11, and of course you're going to use a standard regular matrix multiplication. So of course you would end up doing this. You would just take this row with this column. Then of course, this row with that first column and so forth. So you do this sequentially, but you're going to have a thread. You're going to sort of tell a thread to take this A11 submatrix and this B11 submatrix and multiply that using the regular sequential way. Because, well, at some point you're going to have to do it in a sequential way, but we're not doing the entire matrix A and B, just that quadrant right there. And you're going to write that answer into, well, you're going to write that over here into this matrix, the C11. Let me just go ahead and just sort of highlight. You're going to put that here. So a thread will respond. And of course, A, B, and C are going to just be global. And you're going to just spawn a thread and give the thread some parameters that tells the thread which submatrix of A and B you're going to be processing, and then which submatrix of C are you going to write the answer into. And then what happens is after that, we're going to look at the next component. So now you want to now spawn a thread to, let me just make sure I don't mess this up. I believe you have to multiply this matrix with this submatrix. Next, yes. And again, you do the same work, but you have to tell this thread that I want to take this quadrant of A with that quadrant of B. And of course you have to do it kind of, you have to use that loop, or what I just sort of drew out earlier. You're gonna have to sort of use that loop. You can sort of kind of copy and paste that code online to multiply two matrices, but you have to modify a little bit because you have to really be very careful as to index it properly, so that way the thread will know which elements of A and B will be currently multiplied. That part will take a little bit of thinking. But of course, there really isn't too many ways you can multiply two matrices, so I'm not going to check for copying the general code for that, but you have to modify slightly so you'll know how to be able to really index this submatrix and this submatrix appropriately. But of course, to take this result, multiply A12 submatrix with B12, and of course you're going to write that answer here into C11. So you can just add it into what's currently here. Now, one sort of disclaimer is that what if, remember a second ago we were multiplying, maybe I'll use a different color, I'll use blue to sort of highlight this. So we also spawned this matrix, or sorry, this thread to multiply these two matrices. So the blue and the red parts. Now the problem is that when I have A11 with B11 multiplying in parallel with A12 with B21, in parallel they're going to be working these out, and at the same time they might try to write to the C11 matrix. That's where you want to have a mutex set up, where you don't want to have more than one thread trying to write to any element of C11, because you can have two threads, both can write to C11. And of course you do the same thing for your other cases as well. So pretty much you spawn the threads, and in that handout I gave you, you want to sort of, each multiplication of those submatrices will be a thread function, which will in sequence multiply each of these, but are doing them in parallel. So as A11 and B11 is being multiplied, A12 with B21, and of course the other, other multiplications as well would happen. So that's really the first part. So of course, you can sort of hard code this because you're not going to have to spawn more than 8 threads and not less. You're going to spawn exactly 8 threads to this problem. So you could just literally make 8 thread calls and of course join those 8 threads at the end. So that's your first, that's not your first part, that's going to be really just, the work you have to really do. So of course the hard part is taking your matrix, you have to figure out, the coordinates based on what n is and the sizes of these are, what is the actual, how to actually index it properly. But of course each function call, each thread function is going to be spawned, is going to just be you have to pass in arguments that tells you which parts to multiply. I would suggest just for A, B, and C, make them global, because passing by reference into a thread function is a little bit confusing. So make them global is the simplest way, and then of course tell the function which part of A and B you're going to be working with. So of course each thread function will be able to multiply the submatrices, and exactly can, using the arguments you pass in, it'll be able to figure out which elements of A. So in A11 or A21, what are the coordinates of those elements in that quadrant? Okay, so that's the main idea. Now I'm going to go over a few more extra little remarks just before I end this video. So let's go ahead and get to that next sort of final remarks sort of portion. Alright, so this is going to be kind of the general layout of the program. So at the very top you may see the A, B, and C matrices. That's going to just be your two-dimensional vectors. Now you have to leave a space in between this. Let me just put an arrow here. You want to put a space in between that, because in C++, if you have back-to-back less than, greater than, I don't know what that symbol is called, but back-to-back is an operator in C++, so it's going to cause ambiguity in the compiler. So put a space in between those two symbols like that. So we're simply going to have a vector of vectors. So after you go ahead and you read the input file name and all that, you read in your value for n, this is going to actually allocate an n by n vector. You can of course use this for the B and C matrices as well. So this will first allocate with n rows. Each row will be a vector of n columns. This is going to essentially allocate that for you. So this is just a nice sort of simple way of being able to allocate an n by n vector. And of course you're going to have an array of mutexes. Actually I made a mistake with it's supposed to be I was call it as maybe locks, sorry. And the actual size, I'll leave that to you. Now, I know the problem is, so the vectors can be of different lengths, they can scale, but I mean, no matter what you do, so let's say we have a 16 by 16, a 4 by 4 vectors, the amount of quadrants is not going to get larger. It's always going to be 4 quadrants, correct? So, I mean, that's up to you how you do this, but you could, of course, just have it of size 4. 1 for each quadrant. So you lock a quadrant down when one of your threads is writing to one of the quadrants of your C matrix. Now, of course, when I'm multiplying, so when you're having, let's say, for example, let me just go back up here for a second in my notes. When you're multiplying these matrices, A1, B1, 1, and so forth, when you're reading from matrix A and B, you don't have to worry about locking, because, for example, if I have 2 threads at the same time are reading this quadrant A11, who cares? It's not going to cause any issue. It's only when you're trying to write a value, that's when you have to be careful and lock the threads. So you're writing your results into these C matrices, then you want to lock, but multiplying A11 with B11, or even like A11 and B12 at the same time, so having multiple threads reading the same area of your matrix, that part is fine. You don't have to lock. It's only for the writing portion where you have to worry about locking your threads. So just another disclaimer right there. And also at this point, you're going to spawn your thread functions after you have your A, B, and C's resized, and of course you have to read in your A, B values. And this function, I believe, is going to initialize your matrix all contains zeros. So if your C matrix, you just do this, and automatically every element in C will be 0. But of course, for the A and B, you have to read from your file and populate the A and B matrices. Now, of course, with the vector, once you have it sized like this, you could, in fact, you could just do something like in file A0, 0. And of course, have a loop. Maybe you can have sort of, an I counter for this, and a J counter, have a nested for loop to read everything in. So once you have it set up, you can treat it just like a regular two-dimensional array. All right, so now that you have that sort of part set up, now you have to spawn your 8 threads. Now, of course, what could happen is your program, the unfortunate sort of thing of life and programming is the very first time you compile your program, it's unlikely it's going to compile and run the very first time through. I know it's crazy to think about that, but that is a possibility. So you may want to debug your program. But here is sort of, kind of an interesting thought. Not interesting thought, but here is just sort of, I guess, okay, here's the kicker. Here we go. There's the kicker right now, is that you can't really debug a thread. Because here's how threads work. Once a thread spawned, it really does kind of detach from your int main. It's just going to run. So you can't debug a thread. So if you do want to actually, so let's say, for example, just going back for a second, let's say you have, I'm going to create a thread pool right there. So let's say we have standard vector, standard thread, and I'll call it thread pool. It's not a real thread pool, like as I mentioned in class probably, but this is good enough, close enough to a thread pool. So, so what you could do, for example, is let's say you have thread pool dot push back. And I'll use the thread constructor, so standard thread. And of course, you have as a function is foo, parameters, and so forth, like that. I'm going to actually just copy and paste this, so I can just sort of call it twice. Actually, pasted normal. How about that? So you can spawn 2 threads like this. So you pass in some function, so you can call any function you want. I would suggest don't call it foo, but it's just a good example to show you. You spawn a thread, and of course you have to join them at the very end. But you want to test and want to see what you want to debug these. It's a bit of an issue. So what you could do is you could just comment out these thread function calls. You could just literally just like 135 call foo. Of course, pass in all your parameters like that. And of course, you can call foo again. Pass all your parameters, so you can just simply debug, because really this right here is no different than threading, except it's going to first do this, then it will do this, and so forth. We could do threads. If I spawn one thread, spawn another thread, then they're running in parallel. These are running kind of sequentially, one by one. So you can, of course, this way you can easily debug the program, make sure it's correctly, you're passing in the correct arguments, and each of these functions is correctly computing each Cij sort of submatrix value. And if it's all working correctly, then of course you can comment these parts out, and then you can run them run them in parallel to see if they do correctly work. But I would suggest, instead of calling 8 spawn, just call 8 function calls the ordinary 135 way, just so you can see what arguments are being passed into the thread, so you can kind of accurately can tell it's all working correctly, and verify each function call if the submatrix product is correctly being computed. And then, of course, then try to spawn your A threads instead. So this is very helpful because it's very hard to actually debug threads, but it's easier to debug it like this, because what's the thread really doing? It's just calling a function. So instead of sequentially doing it in parallel, so it's easy to test it like this. So just this will definitely save you a lot of headache if you can just simply debug with this method. So anyway, that really is this video for this assignment. So hopefully this did give you an understanding of how to get this to work. As always, take care, stay safe, and until next time.